Hello, everyone. Really nice to be here. My first Outspace presentation. So a little bit really short about me for those who didn't stalk me yet. So I have had a research experience, but it was more in engineering and material science. Then I figured I would switch to 3D printing project management and also some 3D software for prosthetics project management. And also, maybe you've heard about trauma simulator in VR. So did all of these different kind of experiences and then turned to my, so to say, passion, which is physical therapy. And this is what I'm going to tell about is a postdoc project in Vidzeme University of Applied Sciences. And so the long title is just to, so the focus is mostly on, initially it was on amputees, but I will go into that after. So could you switch to the next slide? So this is a practical applied sciences project with the aim to develop actually a real life product, so to say, based on evidence. And all the activities are performed with keeping that in mind. And so we came up with this logo, and there's a homepage also. Next, please. So the idea behind this is that in physical therapy, specifically for amputees, the physical therapy is really fragmented. And since, of course, it is more important for those people to focus on functionality and quality of movement, then everybody is focusing on learning how to adapt, learning new skills, and all of that. But unfortunately, it's just the surface because the body of movement is defined actually by the core muscles of the body. And what is also important that these populations usually have diabetes, they have heart and respiratory complications and other complications. So for them, it is really important to monitor the vital signs like heart rate, breathing, glucose levels, and etc. So next one. So the solution, which is this project, is to target the deep muscles. And once they are king and strong and fine, that would mean way higher movement quality for those patients. And the vital signs, of course, are being monitored in an individual manner. Next one. But during these last 2 years, I realized that, of course, amputees and population have bigger problems, but the same problems actually relate to low back pain patients and scoliosis patients or low back pain patients. All of them have common issues with muscles, specifically deep core muscles. Next one. So from technical point, what we do is we apply breathing belt, and at this point there's a focus on muscle electromyography. Since you are able to make a movement with not the target muscle, you can compensate it with other muscles. So we need to make sure that the deep muscles are activated, and it's really tricky because they're hard to detect. So we put on the wearables and we put on HoloLens, and then we do the exercising, and the patients see the real-time visual feedback, and in that way they are able to acknowledge whether they are actually activating those muscles or not. Next one. So basically the idea is a game where if the muscles are activated, then an action happens, the game is going on, the scenario is happening. But if the signal is too low or not detected, then you are not able to proceed with the game. Or, for example, the movement is slower, and etc. You will see later. Next one. And mostly it's intended, there is a big benefit for physical therapists in that. There's objective data and long-term monitoring, and you can actually do individual planning of the physical therapy using this gamified environment. This one. And for my experience, how to combine the scientific approach, evidence-based approach, and the practical application. Next one. It has been really interesting and challenging. Let's put it that way, because for example, if you want evidence-based application, you need to perform a human study, use evaluated, certified evaluation methodology in physical therapy, for example. And it's exactly the opposite what the product, how to implement a product. It has to be fast, and in some way the technology has to be already approved, so you can rely on it. Next slide. To share my experience, this was the initial idea about where to apply sensors on a human body during the scientific study. Next slide. And this is what we ended with. And also the parameters, the metrics to measure, you can see ideas are totally different than the reality. Next one. So can I do that? Okay. So what we did 2 scientific studies where we proved that visual feedback, the patient who sees the actual visual feedback, this is from muscle myography. So you put it on loop or something. So in these 2 studies, we confirmed that this seeing actual visual feedback and acknowledging how much higher you can activate your muscles gives really better results. And we did these studies with low back pain population and leg amputees. So both of these populations showed the same efficiency. And so in terms of AR, VR, there is what you see, that's like a scientific version where we needed to have really size time countdown in order to process the data afterwards. Then there is a game version and VR version, and also I will show later 3D printing application. Next one. These were the study results and electromyography sensors, muscles. And you can see the graphs. There is, we had actually 300% improvement in muscle activity. Next one. And this is how the actual exercising looks like. The exercises are specifically to activate deep core muscles, and you can and the sensors, the variables for muscle activity and breathing, those are manufactured in Portugal. And there you see our best friend HoloLens 2. Okay, and the next one. And this is the gamified version. So what we realized, we did this, the latest study was performed using this gamified version, not just the graphs. And what we realized is that, of course, a lot of you from you probably knew that, but I didn't. So I spent a lot of money to realize that how much important is the UI. So basically, the idea is to make the animation in a way that the user intuitively does the exercise or the movement without avatar in front of him showing the specific activity. So, for example, here, the breathing part is really important in physical therapy, in deep core muscles. So, for example, here, if you do breathing correctly and you see the data from breathing belt, then this plant is growing the way it should. If there is no data and you do the breathing wrong, then this plant is not able to grow. It stops in some level. This kind of scenario is for the game. And this is also aligned with breathing. And then for the physical activity, the muscle data are checking whether you are activating your muscles or not, or just forming the movement only with hands, for example. Next one. And in order to ensure the correct positions for the user, for the patient, we are working also on 3D printed sockets where the wearables IMUs are implemented in the 3D printed socket in the specific place, location, and then we would combine all this information in one huge system, which would check breathing, EMG, the location, the change of position, and etc. And also we're adding heart rate, glucose level sensors, and so on. Oh, there's still a lot to do. And next one. I mean, for this kind of application, there are really variety of possible directions where to go. And even if it's not in time and after user tests, we see that maybe HoloLens is too much or whatever, then there's plenty of applications for physical therapy in general, in neurology, in post-stroke patients, strength testing, of course, COVID rehab, and applying neural networks and learning from the actual user's medical data to actually see and sorry, I forgot the English name for that. The future levels of how hard the therapy should be, and so on, and also to prevent some dangerous conditions, judging from the previous medical data. So yeah, we're at the moment we're working together with Vladimir and Tallinn University on next studies, on scientific studies, but trying to make them as simple as possible so it can become a product and usable product. So if anyone is interested in user tests or check the solution in some way as it's possible in the conditions, and just let me know. So, yep. Thank you. Any questions?
I got the mic. Oh, there is Kasper. Here.
I don't see it. Maybe because I have a beer in my hand, that's why I don't see your microphone. Thank you. So, question. I understand that you are looking into this rehabilitation through AR and VR. I have two questions. First, which technology you see that is more or better in this sector? And the second question will be, I asked right away. The second question is that maybe you know the potential market in Latvia, maybe in Baltics or in the world for this VR, AR in rehabilitation.
Thanks for the questions. So it really depends on application, and for example, and basically it depends on the patient population, because for example for amputees, AR is really good because they have very often, because of diabetes and other conditions, they have these cognitive problems. So VR could be really too much for them, and they, of course, we need to still validate this assumption in a bigger scale. For them, AR is better because they are not totally off the reality. But otherwise, of course, VR is way more like spectacular and effective, and you can use VR, the same kind of application in VR for any kind of other patients, like stroke patients or general low back patients, and so on. And the market, I mean, in Latvia, in Baltics, I mean, honestly, my personal belief is that because of the expenses, if you want the real-time actual solution to be implemented, it's too expensive for Baltics. You can, of course, use a mock-up version where you just have the visual feedback, you see the line, and you kind of try to activate your muscles, but you never know if you actually do that. You can just put it on a PC or mobile version or something. That could be an option in Baltics, I think. But otherwise, probably it's international. It's different level of expenses.
Okay, so yeah, it was a difficult question also, like to answer, like what is the potential of this technology in this sector. I understand. So thank you.